Hey students, this video is the Chapter 8 review. If you were here in class, it's probably about the same, but it could be a helpful resource for you to look at as you prepare for the test. So the first thing is, this whole chapter is about perimeter and area. And we did chapters 8.1 or sections 8.1 and 8.2 together, which really asks a question, what is perimeter and what is area, and what are some properties of them? So what is perimeter? The best way to think about perimeter is like a distance around. The distance around some figure. And this figure could be a polygon of some kind. It could be like the floor plan of a building or a lot. You could say how much fence would I need, or how much string would I need to enclose some figure. And so this is be a good working definition, practical definition for what is perimeter. What is area? This would be, you'd be asking like how much paint do I need, or how much grass do I need to mow? And this is measured in square units. It's a measure of two-dimensional space. It's hard to use the word, it's hard to define area without using the word area. So it measures how much is in a region. Measures the size of a region. Another good working definition for us. Early on, we talked about rectangles and how we can develop a shorthand notation for their perimeter, and how we can talk about the area. This is probably old news to you, but as we look at a rectangle, and this is just a schematic, rectangles have 4 right angles. Because they have 4 right angles, my opposite sides are congruent. If that's the case, let's say this side has a length L and this side has a length W. Oh, this should be an L and this should be a W. As I walk my way around, I say my perimeter is L plus W plus L plus W. We can develop a shorthand to say how many L's are there? There's 2 L's plus 2 W's. This is our shorthand for the perimeter of a rectangle. We could even factor out the 2, so we can say perimeter is 2L plus W. 2 times L plus W. And what is the perimeter? The area of a rectangle? The area of a rectangle is either length times width. This is the times, or sometimes we call our length the base and our width the height. So we could call it base times height. This is 2 ways of saying the same thing. So now we have to remember what the special word equilateral means, equilateral polygon perimeter formula, as we look at this next little bullet point that you're charged with knowing. We have to remember quite a few things. We have to remember what an equilateral is. An equilateral is, it means equi-sided, or equal sides. So every side is the same. And polygon just means a closed, segmented figure, and perimeter is the distance around it, and formula is just like some shortcut we can use. So a rhombus is an excellent example of a equilateral polygon. Rhombuses are equilateral, but they are not necessarily equiangular. Equiangular would mean that every single angle is the same measure. And that's not necessarily the case with a rhombus. So let's look at this rhombus. Let's say one side has a length of 2 inches. What's the length of this whole rhombus? Well, every side is the same length, 2 inches, 2 inches, 2 inches. 2 plus 2 plus 2 plus 2 is 8 inches. The perimeter is 8 inches. See if you can think about what would be a shortcut for making a formula for any equilateral polygon. And we say we want to make a shortcut of any for the perimeter of any equilateral polygon with, let's say, n number of sides. We'll call this the number of sides. What are we going to call the length of that side? Well, we can really pick any letter. I'm going to use L. So the perimeter, the equilateral polygon perimeter formula, that is a tongue twister, can be shortened to know the perimeter of an equilateral polygon is L. This is the length of one side. Times n, which is the number of total sides. Awesome. So that's a good start. So now we're going to talk about the fundamental properties of area. The first thing to know about area is it's measured in square units. So if area describes the size of a region, we've got a square unit, which can describe our size of a region. And we do this because this is our basic two-dimensional shape. So a one-dimensional shape would just be a line or a line segment. So we'd say this is 1 centimeter over and 1 centimeter up. And what is the square unit that describes this region? This is 1 centimeter squared. Other examples of square units is we could have a square mile. That's 1 mile. 1 mile. And keep in mind, I don't have to have my scale be 1 and 1. I could have a half-mile edge and a half-mile edge. If I have a half-mile by a half-mile, I multiply both the number and the unit. So when I multiply the units, I'm going to get miles squared, or mile squared. And 1/2 times 1/2 is 1/4. So this square unit is going to be 1/4 mile squared. Another way of talking about area in the world would be like an acre or a hectare. I don't know how to spell that. Hectacre. I'm just not going to spell that if I don't know how to finish it. We could have square kilometers or square parsecs or light years squared or whatever. So that is the fundamental region of area. When you think the fundamental unit of area is a square unit. So when we're talking about those, when we're talking about area, we're going to use square units. The next thing we need to know is the area postulate. And we've got 4 different points. We're going to label these A, B, C, and D. And they're all fairly straightforward. We've got our first one is the uniqueness property. This says a given region has only one defined area. So this is, as I spoke to in class, this is going to point to speaking about areas as functions in the future. But I cannot have a shape that has an area of, let's say, 4 centimeters squared and 7 centimeters squared. This is not allowed. Boo. And that would violate area as a function. And it also just doesn't make sense. So one region only has one area, just like one length or one segment only has one length. The next thing we're going to talk about is the rectangle formula. So the formula for the area of a rectangle, we've talked about that, is its base times its height. Perfect. So let's do an example here. I have a rectangle with a base of 4 centimeters and a height of 2 centimeters. What is its area? 4 times 2 is 8. Centimeters times centimeters is centimeters squared. Is the area of this rectangle here. The congruence property is another one that's nearly self-evident. That says that if I have two congruent shapes, that they have the same area. Two congruent shapes have the same area. That's the congruence property. One application of this is sometimes I'll see things and their orientation may be different, but they are the same shape indeed. So let's use your imagination. Let's say that these two triangles are the same, but they are just oriented differently. They will have the same area. And the additive property says that if I have two non-overlapping regions, if I have two non-overlapping regions, the area of the union of the two regions is the sum of the individual areas. So if I have a rectangle like this and a triangle like this, let's give that a right angle. We're going to say this is a rectangle. This has a base of, let's say, 3 centimeters and a height of 2 centimeters. And so that's a shared side here. And this has a base of 1 centimeter. This triangle is going to have an area of 1 centimeter. That's 1/2 times the base, so 0.5 times its height, which we're going to call, let me label this properly. 1/2 times the base, we can consider either one the base, but 1/2 times the base, which is 0.5 times its height, which is 2 centimeters. So this is 1 centimeter squared for the area of that triangle. Then the area of this rectangle is 2 centimeters times 3 centimeters. So that's 6 centimeters plus 6 centimeters squared is 7 centimeters squared. And that's the additive property of area. The next thing we're going to talk about, and we've talked about this at length, you can look at the other video. I was a little bit tight right there.